Hi, welcome back to Mini Rust in Rust. This is video 46. How long are we going to go on? We're writing a little programming language which it looks like Rust, but it's interpreted. We're using Rust to write it. I hope you're doing really well today. I think we're going to do one more to do in our type checking code to try and get our heads around one more aspect of type checking. Then I think it's time for us to think about things like scopes and functions. Like, it wouldn't it be nice if we could write an actual function and have it return something or something like that? But yeah, that's probably a way away. But we'll get there. All right. So first of all, there's one bit of type checking that I feel like I want to get to, which is like changing our idea about what we know about a type later on. I think that's how it's going to work, but we'll have to think it through. All right. So anyway, when we're type checking a thing, which I'm currently calling a mutation, which is basically like times equals or something like that. I can't remember actually which type of mutation we support at this point. Probably just plus equals or something like that. So we'll start off with the to-do that is written here, but actually we're going to do something cleverer than that. So this to-do says check that you're the right-hand side of a mutation. So like when you're doing x times equals 3, the 3 part is compatible with the left-hand side, the x part. So let's write ourselves a test. Now there might be some tests for mutation that we can put this near to. There's got to be some. I presume. Assignments. While loops. Have I gone straight past it? I mean, if I search for mutations, surely we'll find some tests of mutations. No, not there. Let's just figure out, before we do anything else, let me just try and remember what types of mutations I actually support. Oh yeah, so I think we do times equal and plus equal, right? Yeah. Alright, so there must be some tests with plus equal or times equal in them. Or maybe not. Maybe our first job is to write one. So, plus equal. Oh, that didn't work. Can I search for times equal? All right, it really looks like it. All right, so let's have a test for that. So I guess our first thing will be getting the to-do to work, which is complaining when times equal or plus equal is not a compatible type. So where are we going to put this stuff? It's after like assignments. So maybe around here. Oh, this one is ignored. Does this one now work? Why is this ignored? We didn't tell ourselves why we ignored it, so I guess let's try it. Now, somewhere we had a function called something like type check value, I think it was. We can pass in this bit of code, the type check value, and it should fail. Oh, so we don't want type check value because that, like it says, we just want... I guess we want to do some actual thing where we actually call the type check. Where's an error test? Here's an error test. Let's copy this. We're going to quickly find out why this was ignored, surely. But anyway. So if we just replace the code with that, and obviously this isn't going to be the error message that comes out, but it should look something. It should like return an error from type checking, which we can then compare with something. So let's try that. Oh, I should do it. Probably git status, because did I do a commit? No, I did not. Oh, I'm so terrible. I apologize so much. Okay, let's just put the code back how it was for a second and do a commit. Like that, I think. All right, what did we do last time? We made sums. Yeah, we made adding up two things. Use the most specific type of the two. I guess it's like a constraint type in operations. Something like that. All right, now let's get back on with what we're doing, which was a distraction from what we're actually doing. So, it does cause an error, but obviously it's a different error. It says mismatch type. So let's try and... now, I was talking to someone the other day, and they were suggesting I use snapshots. Inline snapshots, which seems like an excellent idea. I should definitely do that. This bit would be a lot less painful if I did. So there are mismatch types, and it's going to be on line 1, which is this line of code. So I guess we can put that in there. And it's going to complain about how Y and X are mismatched, I guess. So where's it pointing? I guess it's pointing at the X. So it's going to say expected F64 here, I think. So what does it say? Expected F64 found X. I don't think it's going to... I'm not sure what it really says in... Or Rust when you do this. And it appears to have another thing here. We've got this expected due to this. It's so hard to see what's going on here, isn't it? Okay, got that working. Obviously skipped a whole load of me faffing around doing that. But yeah, this is what it looks like. So basically, there was no need to ignore that test at all, because we've now done it, which is cool. Unignore test that checks for invalid type on assignment. Go as. Right, now what we're actually doing is adding another test around here, which says a similar thing for multiplying by an incompatible type. So we'll do something like mutation using incompatible types is an error. So let's let x be an I32, and then let's multiply x by a floating point number, like 0.3. Now we should get an error, and I guess it should have something like this code in it. And I guess it should say, well, let's try out this code in Rust. So we're going to cargo new ourselves a project, multiply wrong type, and we, instead of our main method, we're going to say let x equal 3, x times equals 2.3. Let's put it all on one line like it is. I guess this should be mutable. And it's an error as we expect, so I guess we should make it mutable here as well, just to make it more correct. When we run the compiler over this, it's going to say, okay, it says cannot multiply a sign integer by float. No implementation for integer times equals float. So let's try and get as close as we can to that error message. So let's put it in, and then we'll see whether we're actually able to get close enough. Cannot multiply a sign integer by float. And then it points at the times equals, and it says no implementation for integer times equal float. So we can maybe do that. We won't do that other bit. So we've got some kind of no implementation thing. And I guess, how does it look when there's only 2? Is it going to look like this? There's definitely going to be a dot here. And then that's replacing that line. So I guess we need this stuff on the end of it. We don't need these lines. So when we cargo test, that's definitely going to fail. I think it's just going to allow. Yeah, it did an unwrap error on something that was actually okay. So it allows us to write this code, even though we know that x is an int, so it can't be multiplied by a float. And in fact, let's get rid of the type declaration. So we know it's an int. We don't know what type of int it is. And then this error message will be more like what we're actually going to be able to generate, I think. Well, I suspect we may not make it look as nice as this. Okay, so now we're back to the to-do, which was the subject of this video, which is check the expression as a suitable type. So when we're doing an assignment, we do something like combine with. So let's try that. Something like that. So we've got the left-hand side, which is some kind of symbol. So we need to look up the type of that symbol, and then we need to see whether it successfully combines with the type of the expression. Which means we need to know the type of the expression, and we need to know the type of the symbol by looking up. So where do we look up the symbol? We must do that here somewhere. I guess type constraint, try from symbol token. No, that's that looking at that's the actual type symbol we're looking at there. I want to know if we're looking for a variable that is just, I guess so type checking operation would be a better bet for us. Yeah, so when we type check an operation, we look for the left hand side and the right hand side, and then we try and combine those two. Inside the numerical thing, we combine them. So we first go and look up the types. Where was I? So here. So this, we need to go and look up the symbol in the environment, I guess. So self dot environment dot get symbol dot something. Can we just call it literal but give it file contents? I think it's self.file contents, isn't it? Things are confused in my parser. There we go. Alright, so we're going to get hold of, let's call it left type. What does get return? It returns a type constraint. So left type would be a reasonable name for this, but there is a possibility of an error. So I guess we just question mark it. So now we've found the type, I think, by looking up in the environment, because X must exist, otherwise it's already an error. Like you can't multiply X by something if X hasn't already been defined. So we look up X in the environment, we get back its type, because that's what the environment holds in the type checker. You have this thing called environment, and what it does is holds the type constraint we currently know for that symbol in that environment. And on the right hand side we need to go and look up expression, and that is not going to be just a type, it's going to be a typed syntax tree. Oh, we've already done this. Right, so expression has been replaced by an expression, which is itself a typed syntax tree. I guess we can do the left type before the right type, because that was the way it felt natural for me to do. So I guess we could call this right typed to match what we did in the operation thing. So now we've got a type and a typed syntax tree, which has itself a type. So I guess we can say the final type or something, resulting type, is going to be the left type combined with the right type, which I think right type has a property on it called type, yeah. And that can fail. So this is why we get an error if it goes wrong. Or we might need to do something, because it returns bracket and we need to return error. So we need to do something with that. So I guess we'll do a let else, I think. And we're going to return something which we'll figure out in a second, which means we don't need this, and we don't need this, and we need to say what we return, and we need a semicolon here. So resulting type is then going to be used, surely, to say what the type of this mutation expression is, right? Do mutation expressions have a type, or do they always return the unit type? Good question. We can probably find that out from here. If we make this legal, I don't think we can do let y equal that and have y have a type. Oh, you can, but the type of y is unit, whereas the type of x is I32. So this thing, it has unit type. Even if I put it in a block like that, it's still the same. So, okay, so that means we don't need resulting type for anything yet. We're going to need, in a minute, we're going to need to update our environment, I reckon. But for now, it's not actually going to be used, because the type of a mutation is always going to be unit, which is what we're doing here. So that's cool. Okay, all right. So this is working. All right, so we've got to return an error. And it's going to be a MET error. So let's find somewhere else where we return a MET error, because I still find it's difficult. And we're going to need to make up a new MET, a new error, right? Because type mismatch is not not right. We want it to do this cannot multiply assign. So I guess it's like our new type, error type is going to be, instead of type mismatch, it's going to be something like cannot assign, I guess. So yeah, our words are getting confused. So I guess we're going to call it cannot mutate for now. And when I change my wording to match Rust's wording, we're going to rename all this stuff. So the error was cannot multiply assign blah blah blah. So let's, for now, hard code this stuff like that, just to get this working. And these should be, I think, doubled up. Is that right? To make it not moan about that. Still moaning about something. What's your problem? Oh, I've got to double up these as well to make them go away. Alright, so, and then instead of expected blah, it's no implementation for blah. And there's only one label. No implementation for blah. Double these up as well. I'm doubling these up, by the way, because otherwise it's trying to substitute stuff in. That's what a curly bracket is, like a special syntax it understands. So double it up and it doesn't anymore. There's no due to. There's only one piece of explanation which we give, which is no implementation for blah. And that should be on. It should be on the operator, the mutation operator. Do I call it operator? What do I call it? What do I call it? It's a mutation expression. When I'm parsing a mutation, I call it for operational mutation. If it's a mutation, I just call it a mutation. I don't really have a word for this thing. So this should be now be called, what did I say? Cannot mutate, yeah. Not sure that's a good name, but anyway. So instead of expression, this should be, let's just say mutation operator. That kind of makes it clear enough. It's not very nice looking, but there you go. Right, 2 uses cannot mutate, just one place. And we don't need a due to. What's exp? Do we need exp? I don't think we do. Yeah, there's no expected or found here. Oh, there's the left hand side and the right hand side, but we're not quite doing that yet. So I think we can do it. We can do it. Let's try. So left hand side, let's call them left hand side and right hand side. Even though that's a bit jargony and I said I wouldn't do it, didn't I? So now we can just say left hand side like this, I think. And we could even make this, instead of saying multiply assign, we could say mutation type, mutation name, let's say. And then we put that in here, mutation name. No implementation for, and then I guess we also need mutation, should we call it token? I mean, it's mutation operator, and this is mutation operator span. And then in here we will have left hand side, right hand side, and mutation operator, like so. Hopefully that means that's all right. Obviously there's some commas missing from here. So back to where we're using it. So left hand side is going to be the left type, although we have to like pretty print it in some way. So it's something like left type to error string. Okay, and then the right hand side is going to be, let's put right type to be right typed dot type, and we can use it here. We can also use it here. We don't need a found, and mutation operator span, like so. I think we should put, say, right typed dot span here. That's just a hangover from copying it in from our other code. We're missing mutation name, mutation operator. Those are easy. Mutation name is going to be just a string we hard code. A mutation operator also. We'll fix, maybe these could be better later, but for now, mutation name is going to be multiply assign. Yeah, we'll soon fix this as soon as we do this for plus equals as well. And it's just, the thing here is, oh, but hold on. We could get the literal out of file contents. We could find the full. We can do better than this. We could do right typed dot to error string. Right, I think. Self dot. Although, if it's a complex, I'm not sure. We'll see whether we probably haven't implemented that either. But anyway. So this is an irrefutable let else pattern. This pattern will always match. Oh, I see. Right. So combine with returns a result. So we need to say that if it's okay, do this. Otherwise, do that. Right. So I think we run out of errors. I think we're doing something like what we want to do now. Let's see whether it passes or fails. Okay, well, a bunch of things. Okay, yeah, so there's a bunch of stuff that is type checking where the tests in the evaluator are failing with like a runtime error, but now these are compile time errors. And then we're panicking in the middle of writing those errors because I guess we're not turning things into strings yet, something like that. So these two tests in the evaluator probably need to move into type check, and one of these, this is probably the same as this essentially. So what we're going to focus on? Let's focus on our new test and see if we can get that working. Then we'll go back and fix the old ones. So it's failing because of a panic on type check line 74. Because we don't know how to say, we don't know a pretty way of saying int, but here we just said integer. And while we're here, let's just do float as well. Now, I don't know whether, I don't think we want the curly braces in this string, but I'm not 100% sure. What happens when we've done that? Alright, so we're not far off. We are not far off at all. We are just, it's just a matter of lining things up. So, interesting. It's spanning 3 characters. So it's saying character 21, and we need to move it over a few. So where is our test? Nowhere near here. Somewhere near here. I guess there's times equal in our test. Yeah, okay. So it's complaining about... Okay, hang on. Is it... It's not doing what we want, right? It's not pointing at the right thing, I don't think. Because it's looking at character 21. Oh yeah, that's not far off. Not far off. So 21 is what it's saying here. And then somehow, so this looks the same. Even this stood-in stuff looks the same. Oh well, there's something wrong here for sure, which is I got rid of this part and I forgot to get rid of it from here. That makes it a bit better. 2 semicolons, not sure why. Okay, so my one needs a little bit more space. The dot's in the right place, yep. The dot here is in the right place, but it needs a bit more space before. So we're pointing at 0.3. That's wrong, that's wrong. Okay, we made a mistake. We should not be pointing at 0.3. A sign. There was a multiplier sign, wasn't there? In our code. Yeah, so let's just mark that. Alright, so we should be pointing at... Oh, no, yeah, not right typed. We should be pointing at the actual mutation. Is the mutation token the right thing? I think the mutation token is the right thing. So this should be... Does that have a span? It does have a span, but not a span method, just a span. And I think I need an into to make it work. There we go. Alright, is that any better? Yes. But I have done it totally wrong. Because there should be a line below. This should just... I think it should just be a new line. Yeah, I think the main thing now is a real bug, which is we shouldn't have used right typed as the mutation operator. We should have used mutation token. Does that have a .2 error string? I guess it doesn't. That's not really what it needs. It has a span, and we can look in file contents for that span. Something like this, maybe. .2 ends, maybe. Oh. We need to clone that span if we're going to use it again later. Is that going to work? So close. What's different? What's different? Oh, it's 18 instead of 21. just, yeah, a snapshot would help us so much here. All right, so our new test is now passing. Now we need to make our old tests pass and maybe delete one and move one into type checking. So this is an evaluated test, but it panicked at type check time because that's when it should panic. Yeah, and this is incorrect, so we need to... All right, so basically, I think probably this test needs to go away, but let's double check. Because we've done the same thing already. Although this might be a better name for it. So this test, let's move it out. Oh, there's a load of to-dos and things in here. Yeah, so that I think this whole error type might go away. Right. So back to the type checker. And let's maybe just name our new test a bit better. Maybe multiplying an int by a float as an error is a better thing. Multiplying an int by a float is a type error. And then I don't think we need any of this. We're not going to get to any evaluation because it just fails the type check. And I think I saw just above it is the adding one. Yep. So let's what have I done? Take this test out of the evaluator, put it in to the type checker, and then make it right. So I'll leave the code exactly the same. Trying to add a float to an int. Before we were adding an int, multiplying an int by a float, so that's good. Is that right? Oh, it's both. No, let's swap the sense of this one around then. Let's have this one say this is adding an int to a float. It's an error, so we'll try and add 2 to it. And basically we're going to do the same type of stuff as this. Shouldn't be allowed. I don't think we need any of the rest of this code. And hopefully that whole error message from the evaluator that had all the to-dos in will disappear. Right, so this is cannot add a sign. Let's just check what our code would say. If we try to add a sign and into a float, cannot add a sign. Yeah, okay, so cannot add a sign. Integer to float, or float to integer. And the code looks like this. None of this has got onto the interesting bit yet, but we're edging closer. So we're going to say the error message has to point at the plus equals sign. And we're going to say no blah for blah. Should be float plus equals what? Float plus equals integer. Like so. At. What is the at doing? I think I messed something up there. Yeah, I know what that was. Okay, so go. Alright, so first thing is that it's multiply a sign versus add a sign, so let's fix that. The rest of it looks pretty good. So let's see how we get on once we've fixed that multiply assign thing. So going back to the code, we just passed in multiply assign here, but what we should be doing is saying, asking the mutation token for its like pretty name or something like that. I think we'll do this as a special case. I think we'll do what is this? Let assignment description equal match, some kind of match on the mutation token. Or what is it? Mutation type. Yeah, mutation token dot kind is what I'm actually looking for. And then if it's a mutation token kind plus equals, it will be add assign. Otherwise, it will be multiply assign. Multiply assign. And when we actually pass it in, it's going to be, I guess we could call it mutation name, couldn't we? Anyway, let's call it assignment description for a second so that I can rename it. Mutation name. Okay, that might work. Let's see. We have to swap over left-hand side and right-hand side. That's frustrating. So there's two. This error needs to be. I guess we need to just pass more in. We could have a different error type. Maybe that's the thing to do. I think we should. Okay, so this should be cannot. This should be cannot multiply assign. Multiply assign, and then we can just say multiply assign here. Multiply assign. Blah blah blah, and there's going to be another one called cannot add assign. That's frustrating, but they're sufficiently different that it kind of makes sense to me that they're actually different types. Cannot add assign, and it should be right hand side to left hand side. I think the rest is going to be the same, but now mutation name can go. Okay, and therefore we don't need mutation name here, and it's essentially saying let's just gather the information before we do this stuff, and then we'll do that our match in a second. So we can let source be this. We can let left hand side be this. I think this is the way to do it. Mutation operator be that, semicolon. Oh, we need some equals is there. Yeah, one more. Just because all of this stuff's going to be common between the two different error types. And then based on the kind, if it's plus equals, so I guess we can say we're creating an error which is either going to be a cannot add assign, or it's going to be a cannot multiply assign. and it's going to need some fields in it. Source, mutation operator, left hand side, right hand side, mutation operator span. That all seems right. So why is it moaning? Oh, our problem here is E could be two different types. So we actually, oh, that's really annoying. We have to do I think we have to return errors right here. Is that even going to work? Well, obviously that's not going to work. I don't know what I'm talking about. This should be here. So, can we do this? It's yet error. Expected report found cannot add a sign. All right, let's fill in the rest before we give up on this. Must be something like this that we can do. We don't need it. Oh, we have to call dot into. Yeah, I think we're missing a dot into. And here I can say return error blah dot into. Where does the into go? Before or after the? It goes before the bracket. Okay, is that gonna? Okay. Looks happy. So can we do better? Can we remove the return? We'll just do that, and then return that at the end. The else clause does not diverge. Okay, we need to return in that else clause, of course. So it would be, I guess it would be return here. It's going to let me do that because when I call into, these two branches of our match both get converted into a Miet error. So it's okay for our match to have two branches that do different things because they're both the same type, which is a Miet error. All right, how does that look? We are close. Yeah, it's just line numbers wrong in the test. Should be 21. Is that what it said? Yeah. All right. Wrong one. That one should be 18. And this one should be 21, I think. Hooray, it works. So what did we do? We type checked assignments. Okay, so we've got to the interesting bit. Let's just do a commit here. Not type check assignment, so type check mutations. Very nice. So we've finally got to the interesting bit. The interesting bit, which maybe is for another video. I think the interesting bit's for another video. So the interesting bit is that once we've done this, no, not this. Once we got the positive side of this, where we've multiplied and we are allowed to do it, we actually need to change the type of X, not just check it once. All right. So that's it for this video. Hope you enjoyed it. Next time, I promised we'd get on to scopes and things. We won't next time. We'll do that the time after. But next time we will actually change the type we've got listed for X because of what we learned about it later in the program. That's my plan. We'll see if we get there. Cool. See you then.